Director Wyrick,
Here.
Director Thielke,
Here.
Director Daddy. Unmute.
Yeah, you're on mute, Bob.
Unmute and say yes.
Or put your thumb up. Bob, put your thumb up.
Are you here?
There, he
Are
put
you
his
here?
thumb up.
Yes, okay.
He was
And
here.
Chair Hages. Chair Hages.
Here.
We have a quorum. Thank
Here,
you very
Bob.
much.
Hey, there's Bob.
Can you hear me now?
Yeah.
Good.
Okay, next item is director announcements, reports, comments. Peter.
I don't have anything to report.
Okay. Bob.
Nothing to report.
Bill.
Nothing that won't come up later.
Hi, will you do me a favor? Can you, is this you? No, that's fine. No, it's not. It's gonna just be a bitch to, well, will you give me some eyes on the, as I parallel? Yeah, go.
Well, whoever that is should mute.
Yeah.
Mike Sullivan.
Mr. Sullivan, if you thank you. Jim, I skipped you.
Well, Ojai Water Conservation was able to get a meeting with the county, and Emily and I and Richard were able to meet with Glenn Shepard of the county about the spreading grounds. And Mike Flood of Casitas also joined us. And we started at the lower measuring weir and worked our way up to the actual diversion and injection well field. And ultimately, everybody got a better understanding of the over-engineered, poorly engineered system, and came away with the feeling that in its current form, if we get anything out of it, we'll be lucky. And Glenn Shepard of the county is now going to contact the regulators and see if we can get a meeting with the regulators to go over where this is at, and you know what was engineered, how it sits today. It was discouraging, but at least I think we came out of there all realizing exactly what we've got.
Yeah, I was up there as well. And I think the encouraging thing about it is, you know, as difficult as it may be to operate that facility, it hasn't had an opportunity for us to try it out. I mean, since it was finished, it hasn't rained enough to really give it a good test. And in order for it to work, you have to have some significant flow in the creek after the storm when the water cleans up for a sustained period of time. So, you know, I think it has some potential. You know, if the county can get the regulators to change some of the operating criteria, and you know, and we can get some rain, and we may learn how to use it. So, you know, I don't think it's a complete disaster, but it's an interesting, it's an interesting project. And you know, I think, you know, if the conservation district and the county can deal with the regulatory aspects of it, there's a possibility that Casitas might, you know, at least help in the operations of it. People that monitor the streams and that kind of stuff on a basis. So we may be able to work something out.
Richard, could I ask you a question on that?
Sure.
I'd always heard, not from personal knowledge, the problem was trying to use the sediment-laden water from stream flow for the backflush, and that a separate clean storage tank of backflush would allow more diversion during sediment flows. Is that accurate memory, perception, or not?
I think that was the idea. I mean, Jim knows more than I do. But
Yeah,
solution.
I'll weigh in on that, Bill. I think there's ways, or the sediment doesn't worry me that much if we could do a few tweaks on the system so that water was always going in and out, even with the screens present. That's what we kind of came to the conclusion of.
Okay.
Because even before we open it up, it's sedimented in. You know, with what little rain we had this time,
Okay.
and we barely got to the criteria, it had already sedimented in.
Okay.
So there's some workarounds that have to happen now.
Okay. Thank you.
Okay, any other comments regarding that? If not, we'll move to general manager comments.
Just a couple of comments today. Let me make sure I get my camera right here. I put on the agenda, the groundwater sustainability plan was submitted to Department of Water Resources on time. It is now, they did ask for a letter that I submitted that said the board, because we didn't do a resolution for adopting the plan, and we didn't have the minutes ready. So I sent them a letter essentially outlining what the board had done and how the plan was approved by roll call vote. And they were satisfied with that. So Department of Water Resources has put that document out there for public comment, and I believe it was 75 days. We still have to, they've got a new database system for all of the well data and everything. And that's all been tracked on what they call the CastGen system in the past. And now it's all got to be transitioned over to what they're calling the groundwater sustainability database system. So before the plan can be approved, those are one of the things that we have to do. So I'm working with Jordan and Dudek to get that accomplished. It's not reflected in the financials this month, but the Ventura County Resource Conservation District did provide a $77,000 grant reimbursement for the depth discrete monitoring well. So that's definitely helping our finances substantially. And so I'm glad that came in. We have one more opportunity for an invoice. I'll be working with Jordan and myself and the bookkeeper over this next few weeks to get that final invoice done. We have to get that submitted, I believe, by the end of March. And so there's probably another, but the grant for us was 159,000. There was a local share, but I think we've still got probably $20,000 to $30,000 coming in grant reimbursement requests. So we'll be working on that, and that'll help offset some of the money, well, quite a bit of the money that Jordan spent putting that well in. And then lastly, just as a heads up, unless the world changes, I have a trip planned, be leaving the country on, I think, April 28th for about 22 days. I won't be back until around the 22nd or 23rd of May. So I'm going to France for 22 days. So and that's all I have.
All right. Okay, the next item is public comments. Anyone that has a comment on items that are not on the agenda, and now would be the time to make those comments. Okay, hearing none. Okay, I didn't hear any. Okay, the next item is consent items.
And can we back up there? We skipped over the basin status reports.
Yes, we did. Jordan.
Yes, thank you. Let me hold on one second as we're arranging some files here on the computer. Everything went dark toward the end of John's comments, so hopefully I can share the screen and get this going again here.
Thinking of those 22 days in France, my goodness.
Yeah, I've been to Paris, but I've never really seen much of the country. So we're going to be
I hope you're going to get to South France.
Yeah, yes, we are. Actually, we'll be in Monaco also.
Oh my God.
Yeah. So it's
We're going to come back sun-baked and happy.
Yeah, it's a tour group, and you know, if it's anything, southern Spain was beautiful as well.
Oh yeah.
So, I'd never been to Spain, and that was quite a place to go to. I could enjoy going back there again, especially that southern coast. While we're waiting on Jordan, Chair Hages, did you want to, I can just briefly mention on consent item. I just got the minutes and I didn't get a chance to review them. So, which means you didn't get a chance to review them for January 6th. So we'll bring those back at the next meeting.
Okay.
And hopefully some others as well.
We lose Jordan.
Yeah, I think he's still working on his computer.
Yeah, but I don't see him.
Oh, no, he's not up there. I guess we lost him.
We want to try to deal with a couple of these other items while he's doing that.
Yeah. Why don't we do that?
Do you want to do 8B or 8A?
Trey, what do you want to start with A?
Yeah, I think the order of our presentation, we start with B, so the annual report.
Okay.
So Trevor, go ahead and start the proposed groundwater change method for the annual report.
Let me share screens here. All righty, is the presentation showing okay?
Yes.
In terms of view? All righty. Awesome. Well, good afternoon, everyone. It's been a little while since I've had the opportunity to interact with you, but I'm going to be going over two different topics in today's discussion. First, like Trey mentioned, is a discussion of how we're proposing to calculate or estimate change in storage for the GSP annual reports. And then the second is going to be our initial review of the Ventura River Watershed groundwater service water model. Okay, so like I said, going to largely break it down into two different components. I'm going to try and kind of keep things moving along. If I gloss over any details at any point, by all means, jump on in, ask questions, and I'm happy to discuss in detail where things may be a little confusing. Like I mentioned, let's start off with the annual report. So for the GSP annual reports, effectively, they operate as a data reporting document where we get to report on current groundwater conditions in the basin, groundwater pumping in the basin, surface water, total water supplies. But one of the components that we have to actually make an estimate for, calculate, is how groundwater and storage has changed over a water year basis. That's typically should reflect how groundwater elevations have changed. And the goal here is to be compliant with the SGMA requirements. We need to produce two separate items. The first would be a map depicting how storage has changed across the basin. And the second would be time series plots of how storage has changed historically and how that relates to water year type or precipitation and groundwater use in the basin. So what we would like to do for the annual reports is develop a method that reflects, again, those changes and our historical understanding of groundwater storage variations that are based on the Ojai Basin groundwater model we use to develop the GSP. So again, like I just mentioned, for the GSP, the method we use to estimate storage change or characterize storage change throughout the historical period was the Ojai Basin groundwater model. That's the model that was developed specifically for the Ojai Valley Basin by D.B. Stevens. It's a well-calibrated groundwater model, so it reflects groundwater elevations across the basin relatively well. And it gives us a picture of how these different components of the water budget, whether they be stream interactions, precipitation, pumping, how that ultimately influences the volume of groundwater and storage in the basin. And what we'd like to do is take this information and map it onto measured groundwater elevations that are measured in between these 5-year larger efforts to update the GSP in a way that can say, take a groundwater elevation estimate what the model might give us in terms of a storage change and use that to report how groundwater and storage has changed in the basin from year to year for these GSP annual reports. So that's the broad overview. I'm going to jump into the approach that we've developed currently, and then we definitely encourage your feedback on this if there are any questions. But basically what we're developing is a simple regression model. We have model results shown here in black that characterize how groundwater and storage in the Ojai Basin has changed over time. Again, these are storage change values that are extracted from that Ojai Basin groundwater model. Overlaid on this chart are groundwater elevations measured at well 4 north, 22 west, 5 LO8. So that's right here in the center of the basin in this map schematic in the upper right corner. And what we see when we overlay the two time series on top of each other is that the Ojai Basin model largely reflects how groundwater elevations at this well have changed throughout the historical period. So what this points us to is that there's this correlation between groundwater elevations that are measured at this well in the center of the basin to what the Ojai Basin groundwater model is predicting or has estimated in terms of how storage has evolved in the basin since 1970. On average, we can look at these different types of conditions in the basin. So if we look at the recovery conditions where the basin responds to large precipitation events and recovers to more or less its seasonal high or historical high conditions, the model does a relatively good job of reproducing those. So in periods where, say, for example, right in between 1977, we have a high groundwater elevation that's slightly higher than the groundwater elevation measured in 2002. The cumulative change in storage curve reflects that same relationship. So we have a higher volume in storage in 1978 than we do in 2002. So the model does a pretty good job of reproducing these recovered conditions in the basin. If we look then a little closer at the historical low conditions or the low conditions in the basin, the model does not capture those historical declines as well as it does the recovery state. So for example, if we look at 1990, this is a period before the last drought where groundwater and storage was at a historical low. The groundwater elevation measured at this well was actually slightly higher than what was measured in 2003 or 2004. Now, although the groundwater elevation in 2004 was slightly lower than the 1990 condition, the model tells us we have more volume and storage in 2000 than we do in 1990. So it slightly underestimates groundwater declines, but it does a good job of reproducing the recovered conditions. So what we've proposed to do is generate a regression model that uses these recovered states in the basin or the spring high conditions to calculate or estimate how spring to spring groundwater and storage has changed on an annual basis for these annual reports. So again, just one step back in fewer words, we're going to take our proposals to take spring groundwater elevations and correlate those to how groundwater elevation or groundwater storage in the model changes from spring to spring. So what does that look like? Here's that simple regression. On the primary x-axis, we have groundwater elevations or spring groundwater elevations that are measured at this well 05 LO8. And we have the model simulated change in storage here shown on the right. And the relatively good correlation shows us that at higher spring elevations, we have higher volumes in storage from what the model's telling us. As the spring groundwater elevations are low, we have a lower volume in storage. So this strongly linear relationship between spring groundwater elevations and annual change in storage in the model provides some confidence that we would be able to say measure a groundwater elevation at 05 LO2 and then relate that or estimate what the model might tell us in terms of the storage change value. So why is this needed for the annual reports? Because for the annual reports, we're not proposing to update the model, right? So one way to estimate the annual storage change from say water year 2020 to water year 2021 would be to update the model, incorporate all updated pumping, incorporate recent climate conditions, run the model, and extract that value from the model itself. That's relatively time consuming, and for these annual reports, what we're looking for really is a method that gives us the general direction of storage change over time. Are we increasing, are we decreasing, or what are the relative magnitudes of those changes? This method here is quick. All we do is take a measurement, we can plug it into this regression equation and figure out where we fall on this cumulative change in storage curve to then estimate how much groundwater and storage has changed from, for example, spring 2020 to spring 2021. So relatively simple regression model. What does that look like when we actually implement it and then compare that to the model results? Here again is that same figure I showed 2 slides ago. We have the model estimates of groundwater change in storage here shown in black. We have the groundwater elevations measured at 5 LO8 shown here in red. And then we have the results of those regression models, or for example, the estimated cumulative change in storage based on this spring groundwater elevation shown here in gray. And the comparison between the 2019 cumulative change in storage extracted from the model compared to the cumulative change in storage value estimated using the linear regression we showed in the last slide gives us an estimate of the uncertainty in using this regression model to estimate storage change in the basin. So what we're looking at is a slight discrepancy. We're about 25% different between what we might get from the model and this simple linear regression approach using just one water level elevation measured 05 LO8. Now these correlations can be reevaluated during 5-year reports as the model is updated and we continue to refine our understanding of how the basin responds to different climatic and pumping conditions. Overall, what the models, or what this approach is giving us is, again, yes, please, go ahead.
Who owns that well?
That's a good question. I'm not sure.
Okay. Just wanting to make sure that we have good access to it since we're hanging our hat on it.
Yeah, the 5L8 well is the one right at the corner of Carn and Grand, and it's owned by a number of folks. Actually, I think it's shared among a number of folks, and we've actually used the Elrod well, which technically is 5L5 for much of the data points. It's right next to this well. For much of the data points since 2011, and we have an access agreement with the Elrod family. It was originally signed by John. He's now passed, but the remaining descendants are on board, as is his widow, and she's very friendly and loves seeing us come out there and download the data. And to that end, with that change, it may explain some of the changes you see in this in the modeled results or the storage results. And we've used this regression model or a variation thereof for a long time to calculate the storage in the county before we did, because in the 20-teens we have the continuous data logger monitoring of the Elrod well. We actually don't record the pumping water levels and interpret those as static, which the county previously did and may still at 5L8 up until 2010. So Trevor, I see you nodding your head to that, and that probably makes sense to you as to how this can look more refined as we have more refined data in the 20-teens and beyond. Yeah,
so I guess I'm not as familiar with the 5L5 data. Does it have as long of a record of measurement as L5-8 or 5L8? Sorry.
It's a good question. The county didn't monitor 5L5 as frequently, so it's more sporadic. It is a well that's almost as old and has really correlative water levels for those data points that we do have. But because the 5L8 is owned by so many people and used as frequently as it is, almost continuously, it was very difficult to get both logger down that well and physically and have a good static water level as we do in the Elrod well. Hence, we use the Elrod well 5L5 as what we consider the key well, and refer to everything as the key well area. You'll see that if I get an opportunity to provide our presentation on output and input and change in storage. Apologies for that technical difficulty and for taking the time here to talk about that, but hopefully that answers some of the questions there, Trevor.
Yeah, it does. And maybe that points to, for the annual report, we can take a look at that data at that well as well and see if we can develop a similar correlation that has, or a similar regression model that has as strong of a correlation.
Or if we could just dub it in and use it on ongoing.
Yeah, and maybe that's to the point Jordan was saying, that the water levels at the two wells are strongly correlated. We can come up with a way of relating those two if we don't have measurements at 5L8 to then again plug into this simple regression.
Correct.
Yeah. All right. Well, this is kind of the end all of this estimated storage change. What we need to report for the GSP would be changes in storage from 2019 to 2020 and then 2020 to 2021. We get that, we can extract that out directly from this regression model and then have a value to report in the GSP that reflects how groundwater elevations are changing in this well. Are there any other questions?
Trevor, this is Bill Warwick.
Yeah.
First of all, this is pretty impressive that a simple linear regression model is doing this well. I mean, I remember in my past research days having to deal with all kinds of nonlinear transformation and functional forms to try to get decent predictive effects. But so to get to almost a 90% R squared with a linear model, that's pretty darn good.
It is.
And especially with the more refined data. Just a curious, you probably have experience with other basins and other linear regression models. How does this compare to other predictive models you may be aware of?
It's pretty strong. We're doing a similar approach just south of this basin in the Fox Canyon Groundwater Management Agency. We're having to break up those basins into little kind of smaller aggregates, smaller representative areas to get strong correlations like this. But for a single well to be kind of representative of what the model's telling us for the entire basin, I would say
it's pretty good.
It's pretty good. It was surprising to me. I would have thought we might have had to divide it up into smaller pieces of the pie, but it's doing a pretty good job with this.
Yeah, I certainly take it as good news based on my statistical analysis background. Thank you.
Yeah. Yep.
Any other questions?
Yeah, I have one for Trevor. This is Bob Daddy. Trevor, would you go back 4 slides to the bar graph you have?
Yes. Here.
There. On the bottom on the right, you've got a yellow bar. Subsurface outflows.
Yeah.
How did you determine that? Where's that information coming from?
Directly from the Ojai Basin groundwater model. So there's a component of the model that calculates how much flows out of the basin. I forget the exact number, but if we look just at the colors shown on this bar chart, compared to the other water budget components of outflows from the basin, it's not a large component. Barely shows up on the bar graph. So it's a component we extracted directly from the model. It's relatively small in the grand scheme of things.
Well, I mean, I think that's pretty important, where we're showing that, we're not a major contributor to outside stream flow and interconnectability and other issues coming up. So, okay, thank you.
Yeah.
Anything else?
Real quick, if I can ask, the model that DBSNA developed was for the production aquifers, obviously, for the amount of water in storage. And that's what the regression analysis and the major changes in groundwater and storage are represented both here in this linear regression exercise, as well as the original DBSNA model. It really more or less ignores the perched aquifer system, which is a separate, to my way of thinking, management area of this basin, if not sub-basin in and of itself. The discharge that we know comes from that could be separately delineated, but I think for the purposes of GWR acceptance and annual reporting of the production aquifer system, I think this is about as good as it's going to get. So appreciate it, guys. Thank you.
Okay, if there's nothing else, does any members of the public have any questions or comments? Okay, hearing none, do we want to go to 8A? Or Jordan, do you have?
Do we need to? This was just strictly for reporting. We don't need to accept this methodology or anything.
Good question. Is there any action required, John?
Not unless the board wants to, give some direction to DUDEC, but I think based on what I see today, I think they've given us pretty good information, and unless you want something tweaked, I'd say just allow them to move forward.
I'd be happy to jump back to the previous agenda item and give a quick presentation here.
Jordan, before you do, Trey, did you want to talk about this issue on the Ventura River watershed first to wrap it up?
Sure. Trevor's got a few slides on our initial review of the D.B. Stevens model for the Ventura watershed. The state board is requesting comments by April 1st of this year, which just happens to be the same day as the annual report that's due. And we just wanted to get some direction from the board whether or not we think that Ojai Basin GMA should submit comments to State Water Resources Control Board regarding this report. We received several comments on the GSP indicating that this model was best available data and best available science to develop in-stream flows for the San Antonio Creek exiting the Ojai Basin. And we just wanted to provide some just general comments of our initial review and see what the pleasure of the board was as far as proceeding on this matter. Trevor, can you go ahead and just present the initial comment?
Yeah, absolutely. I think Trey led in nice. I'm going to jump right in. So what is the Ventura River watershed model? I have, like Trey mentioned, just a few slides that give an overview of kind of what the model is, what it was designed to do. And then I jump into some slides where we compare kind of the groundwater elevations simulated by this model compared to the original D.B. Stevens model and how that kind of compares to measured groundwater elevations in the basin. So the model itself was developed with a software called GSFlow. It's a nice software that the USGS has developed in that it's an integrated hydrologic model in that it simultaneously simulates watershed processes. So for example, how precipitation influences runoff, how that runoff is diverted to different stream segments, how local evapotranspiration demands are going to consume some of that precipitation. So that's the watershed component. And then it directly couples that with a groundwater model developed using ModFlow. So there's a continuous communication between what's happening in the watershed, how that watershed affects water stored in the soil zone, how that's water stored in the soil zone then ultimately may recharge the groundwater basin, and vice versa. When water levels are high in the groundwater basin, how that may feed soil zone storage and then be evapotranspired by overlying vegetation. It's a large model. Here, the figure on the right shows the entire extent of the model domain outlined here in this light blue color. And it simulates both groundwater conditions in the alluvial aquifers of the Ventura River watershed, as well as groundwater groundwater conditions in the bedrock formation. So there's a large component of this model that represents how water moves within the bedrock that underlies much of these alluvial aquifers. Per the report, the model was designed to characterize existing in-stream flows and then also characterize unimpaired flows. So what happens to flows in these different creeks when pumping is effectively halted. And kind of importantly, it's designed to estimate that and then also characterize the impacts of water supply and groundwater extractions on these flows in these different creeks. The model itself simulates conditions in the watershed from 1994 through 2017. So that would be kind of at the peak of a wet period down through the kind of later drought that we've experienced in the basin, or really across California. Kind of one of the pieces that builds on the model that was developed specifically for the Ojai Basin was that this model was calibrated both to groundwater elevations and surface water flows. So the original model that was developed for the Ojai Basin used D.B. Stevens' distributed parameter watershed model to characterize natural recharge to the basin. Those estimates of natural recharge were not calibrated to any type of streamflow measurements collected around downstream of the basin, really. This model is. So in terms of that component, the Ventura River watershed model was, the watershed component was calibrated to stream flows collected at 8 different gauges. Kind of the most relevant to Ojai is the gauge just downstream of the basin itself, gauge 605 and 605A. The figure that I'm showing on the right, it was extracted directly from the model report itself, and it shows measured stream flows in black and the simulated stream flows shown here in blue. Generally speaking, the model does a good job of reproducing these stream flow measurements. It captures the peak flows relatively well, and it captures the general declining trends as well. So in the later drought period, we have flows that drop off of our scale here. I haven't looked at the actual raw data, so I don't really know what's going on with these measurements, but overall, it's capturing the decline in low flow conditions during the drought period pretty well. The calibration statistics itself indicate that the model provides a good representation of stream flows measured at this gauge. Now, importantly, because this is an integrated model and the model's designed to simulate the interaction between groundwater and surface water, the model needs to be equally well calibrated to groundwater elevations as it is to stream flows to kind of start to paint the picture of how groundwater and surface water may interact across these different alluvial basins. So here, there's a lot on this slide. Let me walk through a little bit what's going on. The figure on the right here is the general calibration statistics or goodness of fit between the model and measured groundwater elevations in different alluvial basins within the watershed. Here, all of these green X's represent measurements specific to the Ojai Basin. Here on the X-axis are observed groundwater elevations, and on the Y-axis are simulated groundwater elevations. So for a well-calibrated model, for a specific observed head, we should be simulating approximately equal simulated groundwater elevation values. So we would produce more or less a one-to-one line. We'll get to kind of some of these deviations here. On the larger scale, if we look at just how well the watershed or the Ventura River watershed model reproduces historical groundwater elevations across each one of these basins as a whole, we can calculate these calibration statistics, which are shown here with these root mean square error values. In the Ojai Basin, that root mean square error value is approximately 40 feet, meaning that on average, there's this difference of 40 feet between simulated and measured groundwater elevations. So if we jump then back over to this goodness of fit graph, generally kind of in the central, kind of the mid-range groundwater elevations measured in the Ojai Basin, the model does a reasonable job of reproducing those levels. What we start to see is during periods of decline, and I apologize because this orange circle kind of should be shifted down to highlight so it doesn't cut off this data as much. But we have conditions in the model where we're observing groundwater elevation declines well below kind of into the 500 to 400 foot elevation range. And the model is continuing to simulate groundwater elevations that kind of drop down as low as 600 feet, but don't drop much below that. Oops, sorry about that. So we have these conditions where measured groundwater elevations are continuing to decline in the basin, and the groundwater model is not capturing those declines. On kind of the bulk scale, if we compare the calibration statistics from the Ventura River watershed model to the original OBGM model, we're looking at an error in the OBGM model of 27 feet. That Ventura River watershed model is approximately 40 feet. So it's on average less well calibrated than the local model developed for the Ojai Valley Basin specifically. Now kind of to hone in specifically on how surface water groundwater interactions may be simulated using this model, I've pulled out some hydrographs and some specific statistics for wells located along the San Antonio Creek. Those 5 wells are shown here in this table. And each of these wells are color coded using these different circles. And the colors correspond to the well name that's shown here in the table. The values in these 2 columns are the mean error. So the average difference between simulated and measured groundwater elevations. And the bolded and blue numbers here represent the model values that are produced the lower error. So if we look specifically at 32 J02, which is up here in the northern portion of the basin, the Ventura River watershed groundwater surface water model, it underestimates groundwater elevations by about 50 feet throughout the entire simulation. That's shown here in this hydrograph, where we have groundwater elevations simulated that are about 50 feet lower than the measurements in black. In this region of the Ventura River watershed, the larger regional scale model better represents groundwater conditions than the local Ojai Valley model, OBGM model. Same with if you move down a little bit to 05D03. But I'm gonna kind of, now that I've laid the land here for what this table represents, I want to talk a little bit about what these hydrographs along San Antonio Creek tell us in terms of the model results itself. So here, again, the model underestimates groundwater elevations over time, and it overestimates, generally speaking, the fluctuations in groundwater elevations. So there's this enhanced interaction between, it could either be precipitation recharge or stream leakage in this area. As we move down south in the basin along San Antonio Creek at 05D03, this is kind of right in the central portion of the basin, the northeastern portion of the basin. The model does a good job of reproducing groundwater elevations here. It captures the fluctuations in measured groundwater elevations well, and it also captures the general decline during the drought well as well. If we jump down now to 06K03, which is a little farther west in the basin, again, at early time, it captures these fluctuations relatively well, but during the latest drought where we have relatively large declines in groundwater elevations, the model overestimates groundwater head by around 100 feet. So there's this discrepancy between the simulated and observed groundwater elevations at this well and along this portion of the San Antonio Creek where of about 100 feet. I'm just gonna leave it at that. Then importantly, if we jump down to the farthest kind of west well in the basin, this 12H02, here again, the local scale model, the OBGM model, better represents groundwater elevations than the larger scale regional model. And what's interesting here is that on average, the general trend in groundwater elevations is captured with the model. So we have this general declining groundwater elevation trend. But what's being overestimated are these kind of seasonal fluctuations. We have these large dips and these large recoveries in the model that they're reflected a little bit in the measurements, but to a much lesser degree. So what this may point to is that there may be this over connectedness between surface water and groundwater in this portion of the basin, or maybe overestimating the degree of connectivity between surface water and groundwater in this portion of the basin.
So, you know what,
yeah,
I'm just amazed. I had no idea. So this is all for the upper Ventura groundwater model, and they did all of this modeling in our basin?
So they modeled everything in here. All of the alluvial basins are included in this model, and they do model the Ojai Valley groundwater basin. Now they use a lot of the aquifer properties that were originally included in that basin, that in the model that was developed specifically for this basin. So those properties were more or less transferred over and slightly adjusted. But yeah, conditions in this basin are included in the model developed for the regional scale model developed for the watershed.
Huh. I just had no clue that they were so, huh.
Yeah, it's I will say a very big modeling effort. A model of this scale is no easy feat. It's an impressively large model. From a modeler's perspective, it's very big, and it's trying to simulate things kind of on the local scale where those interactions become important.
Well, would it?
Yeah, please.
We'll have more to say later on, but just based on what you just said and what Jim Finch just said, I almost have the impression that they basically use an off-the-shelf model, a very sophisticated model that they plugged a lot in, but didn't put a lot of independent field work in to the model. Is that accurate?
I don't know about the independent field work, but they definitely incorporate a lot of measured data. There's a lot of measured data that goes into the development of the general model structure, how they represent aquifer thicknesses, aquifer properties.
But what I'm trying to say is measured data from other sources, rather than develop from their own field work.
Yeah, I'm not familiar with the level of field work that the model development team specifically did for this model.
Okay, thank you.
Yeah. Okay, so the general take home of what we've gotten from this, again, it's a very initial model review. Effectively, what we did for this review is read the report. We pulled some of the calibration wells that were provided in the report, compared that, but this is effectively the data that's provided in the report. The model itself does locally improve some of the representation of groundwater conditions within the basin, right? We saw that in the northern portion of the basin. The statistics are a little bit better than the OBGM model that was developed by DB Stevens. But there are also issues as we move farther west in the basin where the model's not capturing declines very well. So we saw that 100-foot offset during the latest drought between simulated and measured groundwater elevations. And along, I don't know where my cursor went, along the far western portion of the basin, we saw the models overestimating potentially the interaction between surface water and groundwater. And those are reflected in those large amplitude changes in simulated groundwater elevations that are not present in the measured data. Again, that's an initial assessment of it. There could be, it's an initial assessment of it just based on the model report. We haven't built and run the model ourselves and gone into all of the fine details about exactly what's happening in these different portions of the basin, but just based on how the model is designed and what the hydrographs are telling us in terms of information about what's driving conditions, that's our initial assessment. In terms of use for the GSP, I think what this tells us is that the use of the original Ojai Basin groundwater model developed by D.B. Stevens for this basin is appropriate for the GSP development. It does a better job of capturing the overall groundwater elevation trends when we look at the calibration statistics. It's vertically more refined than this regional scale model, and even with the more refined vertical stratigraphy in the OBGM model, I think Jordan had earlier mentioned that the local version of the model wasn't designed to simulate these perch conditions, and those are further coarsened in this watershed, this larger regional scale model. So overall, from the initial review, we've kind of has led to the conclusion that the use of the OBGM for the GSP development is appropriate, and we'll see how this model is further developed in the future. And this is the last slide I have on this information. I'm happy to discuss it in any more detail if there are further questions or, yeah, yes.
Chair Aegis.
Go ahead.
You know, I may be going out on a limb here, but with respect to your opening question, the direction from this board, you know, why wouldn't we want to respond saying, hey, this is a more predictive model and you should know about it. I don't understand the downside of why we wouldn't want to do that. I may be missing something.
No, that was exactly what I was going to say, Bill. Why wouldn't we weigh in and Trevor, using your technical verbiage, say that based on your evaluation of the two models, you find our model more predictively accurate, R squared or whatever the, you know, it's higher, right, whatnot.
I think for as far as the GSP goes, you know, I agree. I think we should clearly make it clearer that our model seems to be superior. But these two models are going to go on into the 20-year planning process of the GSP.
Well,
each one will be, I mean, they'll have to be calibrated. I mean, we can question what data they're using as we go forward.
But our point, I think, should be, hey, our model could run in their thing for the San Antonio branch so that we don't have two competing models running the San Antonio. Having one model running the San Antonio branch, since we're solely focused on this area and the San Antonio branch, I think that should be kind of what our statement should be.
And that our model is more predictive.
Correct.
Yeah, and if we want to question them, the challenge would be where did their data come from?
Well,
because my guess is they use primarily the county data.
Trey, I'd like you to weigh in based upon that conversation we had earlier today, related to how you think we ought to respond, because it seemed like you were indicating there was some data that was not included in the Ventura River model that we included in ours and generally underestimates the amount of recharge.
Yeah, John, I'll just add at this point that we've reviewed both models. We've received several comments from the non-governmental organizations, from California Department of Fish and Wildlife, saying that we should use the Ventura River watershed model to come up with sustainable management criteria for in-stream flows. And they are suggesting that this model is best available data. At this point in time, we don't think this model is ready for prime time. As Chair Hages mentioned, these models are going to be updated and calibrated moving forward. But certainly at this point, they're not ready to use. They're not sufficiently calibrated. They may not represent the complex geology of the perch system in the Ojai Basin. And our comment letter is basically going to be back to Department of Water Resources, back to the commenters, that the models aren't ready to do what some are suggesting they should be used for. I think it's really important to put that in the record, both in our DSP response to comments and also in a comment letter to the State Water Resources Board due April 1st. And I think if they are intending to use these models moving forward, that it's important to get someone technically involved to comment on the models as they're being developed, and just make it very clear to the regulator that they're not sufficiently calibrated, or they're not realizing the complex hydrogeology of the Ojai Basin appropriately to be used for regulation. So I think that's our point right now. We certainly want to dig into some of it more technically, but I think the direction we're looking from the board is just to develop a letter with Ojai Basin GMA staff and Jordan that we will submit on April 1 to the State Board, and just make it clear that we don't think it's ready to be used for the GSP.
Almost sounds like a motion.
Yeah.
If that's a motion, I'll make that motion, and I hope someone seconds it.
I will second it.
All right, good. All right, you want to call the roll?
So
There, Roberta.
Roberta?
but let's
There
first,
I am, Director Wyrick.
Yes.
Want to restate
Director,
let's do that after, or I'd like to hear it, make sure that it was captured, or get it restated or something.
All right.
Okay.
Sorry, I know that's not Robert's rules, but
Ray, you want to try it again?
Sure. I think the motion is to prepare a comment letter regarding the Ventura River watershed model for submittal to the State Water Resources Control Board on April 1, and basically indicate technically why the model isn't sufficiently calibrated or appropriate use at this time for development of the Ojai Valley Groundwater Basin groundwater sustainability.
but shouldn't it also talk about our model being superior or better calibrated? There's a better word.
Yes, we can put in all the technical lingo in the comment letter.
Well, yes, but
I think to Jim's point, I'll say my motion should be amended to include the superior predictability.
Right. No, I think that's important for the motion, and then your paper writes to that point, which is where you are going, Trey. Yes,
And
that's
we're happy
the motion.
to contribute to that.
That's the motion I seconded with Bill's addition.
Do you agree with that, Trace? You're gonna write it, so are you clear?
Yeah, I think Trevor and I are okay with presenting in the technical peer review a comparison between the Ventura groundwater model and the Ojai Basin model, and just pointing out that the calibration currently for Ojai is more highly calibrated in most locations within the basin, and that currently the Ventura River watershed model does not do a good job of calibrating simulated and observed groundwater heads along San Antonio Creek. And that's really where we have the stream water groundwater interactions and what they're trying to use to develop in-stream flow conditions.
Right.
Bill, is that consistent with your motion?
Yes.
Jim?
Yes, my second.
Right, are there any public who would like to comment on this issue before we vote?
Hi, Richard. It's Bert Handy. How you doing?
Good.
Just so you guys know, the State Water Board is putting on a presentation on the Ventura River watershed model on the 28th, a 5-hour session. Oh, well, I've got, and then they've got 2 days of training on the model on March 2nd and March 4th. So if anybody's interested in watching this model and what they're coming up with, that's a good opportunity to do it. Thank you.
Thanks, Bert. Anyone else from the public? All right, hearing none, you want to call the roll, Roberta?
Director Wyrus,
Yes.
Director Thielke,
Yes.
Director Daddy,
Yes.
and Chair Hages.
Yes.
That's
I keep
unanimous.
getting
Thank you.
skipped. You skipped me there and you skipped me earlier. So I'm
Oh,
Jim,
I see that.
Jim is yes.
Kind of a big oversight.
Well,
By the way, I misspoke just for information. It's actually February 28th. So that's coming up this coming Monday, my error.
Okay, thank you.
Okay, thanks. Thanks, Bert. Okay, next item is, you want, Jordan, do you want to go ahead with your?
Yes, if it pleases the board. I'll share my screen and try to quickly go through our presentation on conditions and a brief description of what's the latest and greatest with the depth discrete monitoring well. Okay, so today I prepared a brief presentation entitled "It's Going to Be an Early Spring," and I bring that quote out because I remember some basketball coaches this time of year, or just about this time of year, saying if you made an exit from the NCAA tournament, you'd probably call it an early spring, and your spring vacation began early. Well, arguably the last drop of rain fell, not too deep into winter, and on the near horizon, there's not a whole lot predicted. Hopefully we get more in March and April, or even into May, but that's hope and not a strategy. So be prepared for an early spring. What that means is that we've gotten just under 13 inches of precipitation, but for a couple of drops that might have fallen this week, that haven't yet made it onto the county records as far as any measured precipitation at the valley floor this water year. Of course, we're measuring what's going in and what's coming out and how it changes at pretty high frequencies. And one of the photographs that I wanted to share, you actually discussed earlier today, and this is the Spreading Grounds rehabilitation project intake structure there. This is a photograph we took yesterday. And you can see there's still water flowing into the basin at this point. It completely infiltrates before long here. And in the foreground there, bolted to the boulder, is effectively the county gauge. It's a 2-inch diameter galvanized pipe with some slots in it. And there's a logger in there that records the water levels, or could be. I didn't open it up to make sure. But this is effectively one of the gauges that the county uses as determining the point of diversion, which is there in the background or midground with the screens and some siltation there at the bottom, right near the water level. So the water level would have to rise adequately high to be able to flow into that structure, assuming it were open via the gate there in the background, and then flow through the hillside spur there through a directionally drilled tunnel that finds its way to the clarifying ponds and then into the passive recharge wells. But it is infiltrating into the basin. Water levels are still rising in the main production aquifers here. We have not yet hit our annual peak, even if we don't get any more rain. The water levels are still rising. Our nadir would have been December 7th at 188.64 feet. We've come up about 14 feet from there as of yesterday, not 635% capacity, but about 63, 50,400 acre feet. At a broader scale, that same well, the Elrod well, this is the measurements that are taken every 90 minutes, as you can see where the well is pumping and where it's not. And that's important because we haven't really had that level of discretization. And as you can see in this graph in general, you've seen it before, but as time marches on the x-axis from 2017 to today, you see more and more data collected more and more rapidly in the recent time frames. Just walking through this chart, the top portion of the graph is rainfall in inches. It's daily. So in a really wet year, 2017, for example, you see some pretty high peaks, but also a lot of storms. Thus far in 2021 to 2022, you can count some half dozen days of rainfall that was significantly measurable, peaking just before Christmas and New Year's at 3 to 3.5 inches per day, and that's days ending at 8 a.m. Of each day. So a storm could have a significant amount of precipitation, but be measured on 2 technically separate days. It basically shows how much it rained and to what degree, and to some level the intensity, which then speaks to the middle portion of this graph, which we've developed to show a number of factors and how the surface water and groundwater have responded. In the light blue is where flow is present in San Antonio Creek across the basin in elevation. So where it's on that left y-axis, you have elevation of 600 feet above mean sea level at the bottom and 880 feet at the top. So when those light blue bars are completely top to bottom, that's when surface flow is continuous across the Ojai Basin. And you can see it's happened every year except 2020 to 2021. We didn't see any continuous surface flow in that driest of years across the basin. We did see flow out of the basin. We'll get to that in a minute. But each year we monitor as the surface flow stops continuously migrating across the basin, where it actually starts again. And it seems to be picking up right in that middle elevation consistently this time of year, right about 760 to 740 feet elevation, which is right about where the edge of the perched aquifer is. So once that continuous flow stops, all that's coming in is at about the elevation of where the perched aquifer exists. Upstream of that, or high elevation of ground surface than that, where the perched aquifer is absent, and you only have the main aquifer present, then you have complete infiltration. But downstream of that is where the perched aquifer is contributing to it. And the perched aquifer itself dewaters. It contains water, it receives recharge, and it discharges water to San Antonio Creek. All of the graphs that you see here going through that, the darker blue is the Elrod well elevations of groundwater levels in that well. The darker blue diamonds are where we've actually taken field measurements of that, and the rest are automated logger measurements. The light blue squares are the GPS points where we've collected data on where the groundwater first daylights as it is leaving the subsurface of the Ojai Basin. Again, largely the perched aquifer contributions. The magenta X's are actual flows in CFS that we have measured over the years. Snapshot, usually monthly, sometimes more, and more frequently lately, as the flows have receded, and not seeing much more than about 4 CFS historically over the time that we've taken these measurements. As you get further into 2021 to 2022, we have the SASCRIP depth discrete monitoring well shown there at the top, elevations of the basal alluvial aquifer there and how that has responded to precipitation, almost like a shepherd's crook there. And the deeper bedrock aquifer also receiving precipitation and recharge, but continuing to rise similarly to the main aquifer system shown both in the Elrod well and the orange line, which is the bottom there of the depth discrete monitoring well in town on Fulton Street, that is still rising. But the yellow line is the perched aquifer within the depth discrete monitoring well. The depth of perforations there are only 14 to 24 feet. And you can see how it spikes quickly and then begins to recede very correlative to the recession in San Antonio Creek. I like this graph because we've developed it over with a lot of thought and a lot of data, and it shows not only the data that we have, but how it's increasing in frequency over the course of the recent years, especially with the funding from the Wildlife Conservation Board grant. What's interesting on this also is that the pink bars are what the discharge rate was measured or at least reported by Ventura County at Old Creek Road Bridge on San Antonio Creek near the confluence. Last month, Chair Hayes asked us or reminded us to pay a little more attention to that. And while we have been paying attention to that, this month we made a bit more detailed assessment of that. And what's interesting is that that daily CFS is not yet available. I don't know if those data exist or if the county is able to share them, but let's talk about what they do. We'll get there. This is how that depth discrete monitoring well responds. It's the exact same graph as last time, but you can see the upward trends in the main aquifer, generally speaking, from the nadir in December, and the relatively rapid response of the perched aquifer, the lighter blue lines, at the same time frame, and then the recession afterwards. Precipitation there on the x-axis again in the magenta bars. There's the deeper, what we call the shallow intermediate water levels, and that's the 140 to 160 foot perforated section. That's actually a gravel unit within the clay, and it may be clay cemented. That's the well casing that is measuring very little changes in water levels. That's the lower blue line that doesn't seem to jump up much at all, if at all, associated with or correlative to either the main aquifer system or the perched aquifer system. So something of interest. San Antonio Creek's response, very flashy, very rapid, and this is from the logger that we have in San Antonio Creek, not the one that I showed in the photograph earlier at the beginning of this presentation that is the county gauge, but rather a logger we have set near the point of discharge of San Antonio Creek as it exits the Ohio Valley groundwater basin. Now, if I take those raw data that we downloaded yesterday, it tells that story a bit more clearly, I think, because those graphs all over the map are pretty, they can be pretty confusing. This, I hope, is a little bit more simple. The upper graph here is, and these are roughly the same x-axis of time, so this will be since December 7th. On the top graph is San Antonio Creek stage, basically the water flow within San Antonio Creek as it leaves the basin. So the x-axis here is about the 2.5 months, and the y-axis on the top graph is, it says 30 to 37 feet, so it's 7 feet. It's not a depth or a stage, it's just a feet above atmospheric pressure in feet. So you can see how spiky that flow is, going from like 33 almost up to 37. So nearly 4 feet of water was standing over this water and flowing pretty quickly, standing over this logger during the December 24th, the Christmas Eve storms. And then thereafter, you can see those 4 storms reflected in a very flashy fashion with a very quick recession thereafter, and slowly regressing again as we've receded flows since. Now, the central graph here is the perched aquifer well that is in the depth discrete monitoring well. This is the 14 to 24 foot depth screen interval. This is all perched aquifer system. So this overlies the thick clay that is present there. You can see how correlative it is to the amount of stage in San Antonio Creek. On the x-axis here, it's about 14 feet. Y-axis is about 14 feet, but the x-axis is the same, about 2.5 months. But you can see how that early December storm has a near immediate effect on water levels in the perched aquifer, and then it begins to recede. The next storm has a near immediate effect, begins to recede. Then the next storm comes along, begins to recede. And the final storm comes along just before New Year's, and then begins to recede, correlative to my way of thinking very much to the surface water flow in San Antonio Creek. Now, The bottom graph, you can guess what that is. That's the main aquifer log, and it's doing something completely opposite. It's just rising. It's increasing in storage. So while the perched aquifer is decreasing in storage and water level, and San Antonio Creek is receding in stage and flow rates, the main aquifers continue to rise to the tune of 15 to 18 feet since the nadir. So how have we measured that basin outflow? As we've made a couple more higher frequency monitoring visits here, because this is a manual gauging point. There's nothing that is there that is continuously recording this. We're taking snapshots of this. So that 1.63 CFS that we measured flowing out on San Antonio Creek proper on the 5th of January was probably higher before then, when the stages were higher. And we can correlate these to some degree and potentially back calculate what the CFS flow would have been on those spikes that we have on the logger data on San Antonio Creek proper. But you can see how through January, the water levels were similar in the perched aquifer, and discharge in San Antonio Creek was pretty similar. And as they began to recede, so has the flow down to 78 hundredths of a CFS as of yesterday in San Antonio Creek proper, and 0.17 CFS out of Montgomery Creek. So just under 1 CFS leaving the basin as surface flow here. Now, that 0.78 CFS yesterday looks like this. It's not a lot, but that's the measuring point at the outflow point of the basin. It's a very thin veneer of alluvium over bedrock, which is exposed on the east and west, or north and south sides of the channel here. East and west in the photograph. This is looking upstream, so left and right, left being north, right being south. Take a look closely at how that looks. Does that look like a lot of flow to you? Does it look like a little bit of flow to you? We measure it at 0.78 CFS, but it looks like a pastoral stream. There's certainly water flowing in it, and it looks relatively healthy. Now, downstream at Camp Comfort, San Antonio Creek is measured by a radar gauge, and the claim as of today's download was 5 CFS, which seems like a lot more, 5 times as much as what we're measuring a mere mile upstream. And I think it speaks to the inaccuracies of remote radar gauging, but it also speaks to the need of a measurement that really creates a rating shift of this kind of data collection. USGS does it at, say, for example, at Foster Park at Casitas Vista Bridge. They'll send out a scientist to measure the flow that then anchors what the radar gauges are reporting. And then they shift the radar gauge reports accordingly. Down at Old Creek Road, near the confluence of the Ventura River, there's that photograph that I took yesterday with very similar flow to what you saw coming out of the Ojai Basin. But yet the radar gauge is telling us it's 13 CFS. And that is not 13 CFS. It looks slowly flowing. It's not very deep. And I would venture to say that it's significantly less than 13 CFS. So one of the things that we'd like to do is get down there and hey, somebody should do a rating shift of these data points, because otherwise these data are going to find their way into the data sets that then inform management and policy, if not litigious decisions, and be wrong. We don't want that. We want to have our boots in the ground, our feet wet in the water, and measure what that flow is. And that needs to be done. The county should be doing it. The USGS does it on the gauges they monitor on the main stem Ventura River. And I think it's significantly important. If someone were to look at this and say, aha, 13 CFS at Old Creek Road, 1 CFS leaving the Ojai Basin, where's all that water coming from? It's not. The actual flow is not correctly depicted. So with that, perfect storms and perfect recession. I think we had some perfect storms. Hopefully we get some more. A couple changes up over last month. We've gotten over 4,000 acre feet of water recharged to the main production aquifers, and probably a significant amount, potentially as much as half of that to the perched aquifer system, and rapidly discharging over the course of the latter months of winter here. We've had over 10 feet of water level rise in the perched aquifer, but begins receding as soon as the rain stops. San Antonio Creek discharge, again, hydrograph correlates with rainfall and the perched aquifer and recedes very quickly while the main aquifer water levels continue to rise. So that completes this presentation. I will speak quickly to our plan for the Discrete monitoring well and what we're doing there in the coming weeks. As John mentioned earlier on, the Wildlife Conservation Board grant has to be completely invoiced for encumbered funds by the end of March. So over the course of the first 2 weeks of March and the last week of February here, we're actually going to do another round of water quality sampling and importantly pumping on that well. We're going to add a number of, we have existing loggers in there now collecting data, but we're going to add additional loggers and a small pump to those wells to monitor what happens to the water levels in all 4 of those casings as one well is pumped, so that we can actually calculate a transmissivity or a hydraulic conductivity of the perched aquifer and a vertical conductivity if there's any response to anything below or above the pumped zone. We'll do that when we pump the perched aquifer. We'll do that when we pump the main aquifer, the intermediate deep, and the intermediate shallow. And I suspect that the intermediate shallow casing will actually become dewatered and not provide much recharge whatsoever, because we're not seeing any response of that zone encased within the clay between the perched aquifer and the main aquifer system respond at all to the precipitation. Still lots to learn, and that's what we love about working here, is that as long as we've done this, we continue to learn, and that drives the passion of dispassionate science. So, any questions?
Jordan, if with the chair's pleasure, I do have one.
Sure.
That's pretty stunning. 5 to 13 times or more order of magnitude error in measurement of surface flow that may be being used for, as you put it, litigious purposes. I also would like to mention that, of course, there's a status conference with the court tomorrow. The joint exhibit list, witness list, trial briefs, and pretrial motions are due by March 2nd. And the trial begins on March 16th. To the extent that this documenting this divergence of actual versus measurement may be relevant to what's going on here in the trial, it seems really important to document this now. And I'm going to go out a little on a limb here, because I can tell you that we've had several comments with discussions of this in City Council, and I'd certainly be willing to go to, we have some budget for this, and I'd be willing to go to my city manager and colleagues if the OBGMA doesn't have the money to pay for this documentation right now. I'd be willing to go to the city and see if we could pay for it, if it's as relevant as it appears to be, to document this immediately.
Yeah, I think to that point, we do have, as John mentioned, a pretty good budget still under the Wildlife Conservation Board grant, and the pumping and the testing, as well as the in-stream flow monitoring that we've been doing, is all encumberable by that grant, including the reporting therefrom. So I think we're going to get as far as we can within that budget and see where we land after St. Patrick's Day, and potentially be looking at continuing this monitoring either with additional Wildlife Conservation Board grant monies or OBGMA or other stakeholder funds.
Okay. I want to make sure we do what we can to get this information, this documentation done, because we're coming, it's very timely.
Yeah, and it's presented here in this way, but we've known about it for a long time, and there's quite a bit of data within the record, shall we say, that demonstrates this as well, and we can speak to it when the time is appropriate.
Okay. More data better than less data. That's all I'm saying.
I agree.
I think the thing that
As long as it's defendable and defensible and repeatable.
the thing that's telling is really the only data we historically have on flows at San Antonio Creek are down at the confluence, the county's gauges. And if those are incorrect, and that's what's been used, you know, all these years to estimate how much flow comes out of the valley, that's pretty significant.
Yeah, I think along those lines, the county gauges on San Antonio Creek really were or are intended for flood alerting. It's part of the alert system, and it's not the classic USGS style gauging systems and stages and with rating shifts and curves that adjust to true conditions. These are, is there going to be a problem downstream gauges? And the problem is that oftentimes that's misconstrued and forgotten that that's what their intent is. And that 13 CFS, someone clicks on it, they think there must be 13 CFS in the creek flowing under Old Creek Road Bridge. That's not the case. It's pretty clear to me. And unfortunately, just because the water level is at that elevation, it ignores that, well, the channel is filled with gravel or sand, as opposed to being completely culled out to bedrock or the apron of concrete underneath the bridge that is the base assumed elevation, and therefore a higher cross-sectional area and therefore more flow when the elevation of the top of the water is what it is, as determined by the radar gauge. So there's a lot of tools in the toolbox that aren't being used, that's for sure.
Well, it's probably, since it's for stern flow, it's calibrated with a minimum flow of 10 or more CFS. So once it drops to
yeah, and that would make sense that it's zero at zero flow. It's recording 10 CFS.
Yeah. Any other comments, questions?
The only thing I'd say, this is Jim. It was interesting seeing water, even though it was just kind of standing at the diversion screens, because on Friday when Richard and I were there, that was completely dry.
Right. And it's interesting because I think part of that may have to do with how cold it's been lately. And for a long time, you know, we've worked on the idea that the biggest point of output is often trees in the headwaters. And when it's really cold, they're not taking up a whole lot of water. The native vegetation in the watershed. When it's really warm, they take up a lot of water. So on weeks like this, when it's bone chilling out there, the trees aren't transpiring very much water in the headwaters. So it allows more stream flow, spring flow, and surface moisture, soil moisture to discharge to those creeks above the basin, which is good for the basin.
Right.
And you see that flow today when you wouldn't have last Friday when you were there. And we see that kind of thing change pretty rapidly in all of these basins in the watershed on a daily basis.
Well, we had rainfall in the upper reaches of the mountain range, though.
Yeah.
This couple of days, last couple of
days. Yeah, it was amazing how much snow there's been around on some of the local mountains too.
Not here.
No.
So you could see snow on Pine Mountain, little streaks of it yesterday.
Just a light dusting.
Yeah, I had a report of chains up there at the crest at one point. Change required even.
Yeah, 5 was closed for a while.
Yeah.
All right. Thank you, Jordan.
Thank you very much.
Richard, can I say something real quick?
Sure.
Yeah, that's pretty handy. Jordan, are you familiar with Ventura's gauges down there above Foster Park that they're doing? They've got stream flow gauges in there. Are you familiar with those?
I'm familiar with some of the monitoring wells that have continuous recording data loggers in them adjacent to the river in Foster Park, and of course the Casitas Vista Bridge. But I don't know of any others personally.
Well, what's happened is with the adjudication thing and the Ventura River thing, Ventura had to put in a couple of gauges above and below their wells to take out water. So they've got a continuous file on all the river flow. I just pulled it up right now to look at it, and that river flow, stream flow, is actually showing 13 CFS. So I think that's historically there, and I can get you the data, and you can go back into it to see what's going on compared to what you have, because that's probably going to be an issue.
Wow.
Well, that's an interesting lucky 13.
Yeah.
If, it may lead one to think, well, there's 13 CFS flowing in the river at Foster Park, and look, there's 13 CFS flowing from San Antonio Creek.
Uh-huh.
And that's why I'm bringing it up to you, because I think you should really evaluate that to see what's going on.
Might be worth a look, Jordan.
It may be worth a look.
Thank you, Bert.
Yeah, Rich, you have my email. Have Jordan get a hold of me and via email, and I'll send him the link to it.
Yeah, I can give me your email. Thank you, Bert. Okay, next item. We're running along here. Item C, City of Ojai's request for membership in Upper Ventura River Agency. Bill, you want to speak to that?
Yeah, I'll be real quick about it. Everybody can read it. We have submitted, I think, everything that's happened at today's meeting. What happened at the last couple of their meetings only underscores the importance of this. The letter is fairly self-explanatory. We feel that about 1/4 of the city limits are in the adjacent GSA's jurisdiction. That's not counting the sphere of influence and land use which is a much larger part. Land use responsibilities are a core qualifying criteria for membership in the GSA. We feel like we have a strong case for that, especially going forward with implementation of plans, management plans that would include this city, obviously. We've also talked about, as a council, internally, I can characterize the discussion about we understand a significant monetary contribution would be involved to join this GSA, and we are prepared to pay it. We asked to be on the next board meeting. The response from Mr. Bondi has been that he's going to simply make an executive director report to the board at this point and see if the board wants to put it on the agenda. We feel this is a serious defect in terms of the current situation with this GSA, and we think it's important. And I think, if nothing else as well, what we have just found out again today, where they made assumptions about a neighboring groundwater sustainability agency without that neighboring groundwater sustainability agency actually knowing what was going on with their modeling. And arguably, if that communication had been in place, the modeling would have been a higher quality. Another reason for the city to get on to the membership of that GSA. So that's what we've done, and I really appreciate the opportunity to put it on the agenda and to let everybody know what we've done and see if there are any questions.
Question?
Jim?
So I fully agree with everything you've said in the letter, Bill. Would you like us just a motion in support of the city's position?
I would love that if the board is so inclined.
Well, I'll make it a motion in support of the city's position to get a get a seat on the board of the Upper Ventura River.
Okay, thank you. We plan on attending the next meeting.
Who is the second?
I'll second it.
Okay.
Thanks, Peter. Okay, Roberta, call the roll, please.
So let me quickly, does Bill, can you vote on this, do you think?
I'm going to wait, Mr. Candy or Chair Hages. What do you think on that?
Even if you don't vote, I don't think it matters. I mean,
It doesn't.
I mean, you could.
I do represent the city. That's my job
Right.
on this board. So
Yeah.
I think I could vote yes. Go ahead.
Okay.
I believe you can vote as a representative of the city on the OBGMA board. I believe you can vote and do not need to recuse yourself.
Thank you.
Hey, Roberta.
Director Finch,
Yes.
Director Wyrick,
Yes.
Director Thielke,
Yes.
Director Daddy,
Yes.
and Chair Hages.
Yes. All right.
Unanimous. Thank you.
Forgot to ask, but if there are any member of the public that would like to comment on that. If not, we'll move to the draft budget. John.
Yeah, bear with me just a Roberta, something?
Does Betsy Stick have something to add?
I would love to say, I just want to say thank you, Bill, for bringing it to this group. And we're really excited to get somebody on there. And I would love to be on there. So grateful to all of you for doing this work and collaborating. And I look forward to, working together. So thank you.
Thank you, Betsy.
Thanks, Betsy.
Thank you.
Okay.
I'm just trying to see if I can put my agenda up here real quick. Did I do that? Are we seeing this on the screen?
Yes.
Okay, hopefully. I didn't mean for the whole program to show up, but just want to get down to the couple of slides. I don't want to spend a lot of time on this. I did update the cost of service analysis, and primarily, I don't know if you can, let me see if I can get this a little bigger. There. The biggest problem I was having with all of this is some of the costs that were put together by DUDEC, and not that I have an issue with their costs, I just don't quite understand it all. And so I did include this table that DUDEC provided in the groundwater sustainability plan. It's 20 years of budget, operating budget, as well as GSP expenses. I did plug that information in the model, had a few tweaks here and there. At the end of the day, the normal extraction fee that the agency has had would cover the normal annual operating revenue. But when we start looking at GSP implementation, there's going to have to be a continued fee on the groundwater extractions for the groundwater sustainability plan activities. So what this table, what I represented here was, originally we had showed that the GSP fee in the 2022-23 budget would be reduced, I think, about half. And then in the 23-24, it would be zero. But this table that I put together in front of you indicates that based upon the numbers that DUDEC showed us, we'd have to sustain this groundwater sustainability extraction fee through the next 5 years as minimum, and probably beyond. I'm not ready to make that recommendation tonight. What I'd like to do is, and again, I don't want to get into all the little details here, but this table did show the operating revenue and then the GSP revenue and the expenses for the GSP. What I'd like to do is look at this, and this essentially came from our bookkeeper, but it really is just kind of the operating expense along with the revenues for both operating and GSP. And so what I'd like to ask the board to do is adopt a budget that's consistent with this table, but subject to not authorizing at the bottom down here, this 193,000, subject to not authorizing that amount at this time, essentially approving a budget for operating expenses. And let me come back to you with a little more detail about the GSP expenses and where that might fit in, because ultimately that's going to determine what if any additional extraction charge needs to be put forth or sustained. Guess that's all I really have. These are pretty much a 1 year expense, and this doesn't give you a fund balance. I think it just shows you if you continued the $37 on top of the 25 for groundwater extraction, you'd get $300,000 of revenue. You'd have low operating expense of 104,000, and you'd have a net of 201,000 to use toward groundwater sustainability, with a net income for about $8,500. Like I said, I'm not ready to recommend that the board approve groundwater sustainability budget at this point. So I just ask you to essentially approve the general income and operating expenses, not shift the groundwater sustainability extraction fee at this time, but I'd like to come back in the next couple months and give you a better view of where I think this needs to be. And I need to talk to Dudek about some of this. So essentially I'd be looking at income through net operating expense would be the suggested budget for this current fiscal year. Any questions?
Chair Hages, I'd make a motion that we adopt that and get this thing back in a couple months with some other ideas on where we need to go with this. So I would make a motion we adopt this for today, and then have this thing come back by what, before the end of May? That enough time, John?
I'm going to be gone for a month.
Ooh,
almost.
When?
April 30. I'm probably leaving the town on the April 28th, and I won't be back until before the board meeting in May.
How about by the board meeting in June?
Yeah.
The trouble though is, by my count, I mean, you're shy by
84,000.
Yeah, which I'm just guessing in my head is $20 an acre foot. Wouldn't we be better off? And by that point you are, I think you'll be
6 months shy.
No, because we're not on calendar year. You'll be, I think you'll be 3 into it, 3 quarters into it, and only have 1 quarter left. Are you better off just raising the GSP extraction fee to $50? It doesn't make up the full $20, but it raises it 30.
Yeah, I would like to, yeah, and that assumes the expenses are as presented for the GSP implementation. I'd like to hold off on that until, again, I can massage the numbers a little more, and then we can, then I can come back to you and say, well, it ought to be no more, it should be $20 or something in between.
But if we run, see, if we have it in the bank, we can leave it in the bank. If we don't have it in the bank when we need to write a check.
Yeah. Well, Jim, the other issue is if the board wants to move in that direction, there's a whole public notice requirement, and we're going to have to send out notices to people and put it in the newspaper, have a public hearing. And
even on the GSP side, does it still fall under 218?
Yeah, we went through that the last time when we raised it to $37. I think, Peter, if you're there, can you chime in on that?
Yeah, there's procedures that we need to look at and make sure that we're compliant with. And these are procedures that come up through Sigma separate and apart from the 218 process.
Okay. Well, let's look at them, because I'm afraid we're going to be behind the 8 ball.
Well, the good news is the groundwater sustainability plan is pretty much wrapped up. We might have a couple few dollars left there. We got the annual report. So I don't think we're going to be behind the curve this year. But if the board starts implementing groundwater sustainability plan projects and management actions, then we could probably get behind the curve real quick.
Okay. And hey, trust me, I'm a person who writes it. Oh.
Okay.
Okay. So I'll second. Was there a second on Bob's?
No, there wasn't.
I'll second it.
Thank you. And again, this is only for that portion of the operating budget, and I'll come back with much better information on the GSP expenses.
Any other questions or comments on this? If not, Roberta, going to call the roll?
Director Finch,
Yes.
Director Daddy,
Yes.
Director Thielke,
Yes.
Director Wyrick,
Yes.
and Chair Hages.
Yes.
Thank you.
Thank you.
Good. Next item is Treasurer's Report.
Yeah, again, I'll just be brief on that. Let me get to my notes. In January, the bank balances increased by a little over $11,000. The particular January report does not reflect the money we got for the grant reimbursement. So that'll show up for the February report that you'll see at the next meeting. The operating expenses for January were down a little bit due to lower expenses in professional fees. However, we did have expenses related to the grant, so those were around $20,000. Again, a lot of that grant expenditure is going to be reimbursed, and we'll be getting that together, as Jordan mentioned earlier. The extraction report, I think I reported on this last month. The reported extractions for the last fiscal year were 4,357 acre feet with a $291,383 revenue income. And as I mentioned earlier, the final grant expense and reimbursement requests have to be filed by late March. So we'll be getting that together. I'll be working with Jordan and we'll get that over. And again, that could be $30,000 to $50,000 more. And then there's some retention. Every time we put an invoice, they withhold about 10%. So assuming we get all of our information to them and they're happy, hopefully we'll see that additional 10% come back to the agency. That's all I have. Any questions?
Okay, if there's no questions, we'll move to the next item. The next item is.
I'd appreciate a motion to accept.
Okay, I have a motion to accept the Treasurer's Report.
Move to accept, receive, and file.
Second.
Call the roll.
2 seconds, Derek. Director Finch,
Thought it was Director Thielke.
Yeah.
Yes.
Second, yeah.
Yes.
okay.
That was
Director Finch,
Yes.
Director Wyrick,
Yes.
Director Thielke,
Yes.
Director Daddy,
Yes.
and
Thank
Chair
you.
Hages.
yes.
Thank you.
Okay, next item is election of board officers. We usually do this in January every 2 years, but we were a little busy in January. So currently we have 2 officers. Director Finch is the vice chair and I'm the chair. So I'll entertain nominations for those, first the chair and then the vice chair.
I would like to nominate, if they're willing to continue, that these 2 officers continue in their present positions for another term, if willing.
Yes.
Yeah, yes.
I second that motion.
Thank you.
Good. Stick a roll.
Director Finch,
Yes.
Director Thielke, Director Thielke,
Yes,
Director Wyrick,
Yes.
with great
And Director-
appreciation.
Director Daddy,
Yes.
and Chair Hages.
Yes.
That's a unanimous.
All right, well, thank you, everyone.
Thank you.
A lot of work tonight. We got
Yeah.
So we're
Good
going to
meeting.
adjourn. 4:49 is the adjournment time.
yes.
Thank you.